Okay, so now we're at example 2 and we're doing the same thing as we did in example 1 above. Just this triangle has different side lengths. All right, so maybe you want to try this on your own, or maybe you just want to stay tuned and listen. But first, let's just do angle A again. And again, the hypotenuse is always opposite the right angle. In this case right here, adjacent is 8 and opposite is 6. All right, and again, incredibly tedious, sine of angle A. That's going to be opposite over hypotenuse, which is going to be 6 over 10. And we're going to reduce 6 over 10 reduces to 3/5. Cosine of angle A is adjacent over hypotenuse. Adjacent is 8, hypotenuse is 10. 4/5. Tangent of angle A is opposite over adjacent. The opposite side of angle A is 6. Adjacent is 8, and it reduces to 3/4. Okay? These numbers kind of seem familiar. Let's just keep going though. I wonder why they seem so familiar. Angle B, now with respect to angle B, the hypotenuse does not change, but the opposite and adjacent sides swap. 8 is now the opposite side. Adjacent is now that. Okay? So sine of angle A, opposite over adjacent. Opposite is going to be 8 over 10, which reduces to 4/5. Cosine of angle A. Oops, hold on. Small typo. Sine was opposite over hypotenuse. Opposite over hypotenuse. I still have the right numbers down. I just accidentally wrote down the wrong word. Adjacent over hypotenuse. So 6 over 10, or 3/5. And then tangent of angle A is opposite over adjacent. In this case, it's going to be 8 over 6 reduces to 4/3. So notice something. All right. What do we notice in example 1 and 2? The trig ratios are the same. For angle A, we have 3/5, 4/5, 3/4. That's what we got down there. Then for the sines, or not the sines, but angle B, we have 4/5, 3/5, and 4/3. They're the same, all right? Trig ratios were the same for each angle. And this is why trig's so powerful. This is why it's so important. This is why it's so useful, is that the trig ratios are going to be the same. So when these ratios, so say you have the sine of some angle is 3/5, well, that forces that angle to be about 37 degrees and about 53 degrees. That's what Harpakis, our dude up here, that's what he did. He figured out given the ratio of two sides, it forces an angle to be a certain measure. So up here, since we have the same ratios, that's also 37 degrees, that's also 53 degrees. So it's really just given side lengths for a right triangle, we can determine the exact angle measures using trig. Very powerful, very useful. Just think about if you're building a roof and you need a certain length and slant to your roof, you can figure out the height of it, and just building stuff, so important, right? Now, how do we know which trig ratio to use? We have our good friend SOHCAHTOA, all right? So we're gonna read it down like this. So sine is this first block of stuff. So remember, sine is gonna be the opposite over the hypotenuse. This next block of stuff, we got cosine. Cosine is the adjacent over hypotenuse. And then tangent is opposite over adjacent. All right, so you read this straight down. SOHCAHTOA, this is a word I made up to help you get students remember which sides to use for which trig function, sine, cosine, and tangent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. SOHCAHTOA, I made it up. And again, just to emphasize things, how it all relates, that's 90 degrees, that's theta, opposite, excuse me, brain fart, adjacent, opposite, and then hypotenuse. All right, and that's that. All right.